Hello students, welcome to the lecture of structure of atom. In the last lecture, we have studied about the shape of the orbitals and the energy of the orbitals. We had discussed about the boundary surface diagrams and how to calculate the number of nodes and how to determine the shape of orbitals, etc. Today we will start about how to determine the electronic configuration of atoms. So, we had studied about the boundary surface diagram of orbitals. We had discussed about the shape of the orbitals. We know that S subshells are drawn in the spherical form. P subshell which contain 3 orbitals Px, Py and Pz, they are described in this dumbbell form and it can be along 3 axes x, y and z, and the d subshells have 5 orbitals among which 4 of them are drawn in the form of double dumbbell and dz square is drawn as a dumbbell and a ring, right? And we had also drawn how it looks with respect to the x, y and z axis. Then we had discussed about how to calculate the node. So, we had seen that for S subshell, number of nodes was equal to n-1. For P and D, number of radial nodes was n minus L minus 1 and number of angular nodes were L, that is the azimuthal quantum number. After that, we had discussed about the energy of orbitals. While discussing the energy of the orbitals, we came across a rule called the n+L rule. So, we will learn about some new rules and then we will start the electronic configuration. So, first of all, we will revise the n+L rule, then Aufbau Principle, then Pauli's exclusion principle, and Hund's rule of maximum multiplicity. So, let's start with revising the n+L rule. What was the n+L rule? It said that the sequence of energies of different subshells is measured by the sequence of their n plus L values. Okay. So, the sequence of energies of different subshells is measured by the sequence of their n plus L values. So, lower n plus L value will mean lower energy. Okay. And if two subshells have same n plus L value, then we will consider the n, that is the principal quantum number. N will be considered. Okay. So, at that time smaller n will mean smaller energy. Right. So, we will see some examples. So, 3D and 4S. Okay. So, in this case for 3D n equal to 3 and L equal to 2. So, n plus L will be 3 plus 2, that is 5, and for 4S n equal to 4 and L equal to 0. So, n plus L is 4 plus 0, that is 4. So, we see that n plus L for 3D is greater than n plus L for 4S. So, from this we can say that the energy of 3D is greater than energy of 4S. Now, if we consider 3D and 4P. So, for 3D n plus L was 5. Now, for 4P n equal to 4 and L equal to 1. So, n plus L will be 4 plus 1, that is 5. Now, both of them have n plus L as 5. So, now we will consider the value of n. For 3D n is equal to 3 and for 4P n equal to 4. So, n of 3D is less than n of 4P. Therefore, for here energy of 3D will be less than energy of 4P. So, now we have learnt n plus L rule. Now, based on the n plus L rule, there was another principle known as the Aufbau Principle. Now, Aufbau is not the name of any scientist. Aufbau in German means building up. So, we will learn what will be the sequence of the filling of electrons in the subshells. Like electrons will fill up in which subshell first, and after that which subshell will be filled, and so on. So, the sequence of filling of orbitals or filling of the subshells was given by the Aufbau principle, and it was based on the n plus L rule. So, Aufbau principle gives a sequence in which subshells are filled depending on their energies. Okay. So, in the ground state of the atom, what is the ground state? The ground state is the lowest energy state, that is the most stable state. So, in the ground state of the atom, the subshells are filled in order of their increasing energies, that is, the subshell with the lowest energy will be filled first, increasing energy. Okay. So, now what was the sequence? We will see what was the sequence. So, what is the first orbit? The first orbit is n equal to 1, right? So, for n equal to 1, how many subshells are possible? Only one s is possible. Now, n equal to 2. For n equal to 2, we can have 2s and 2p. There will be no d orbitals because n equal to 2 has only 2 subshells. Now, n equal to 3. We know that the number of subshells in an orbit will be equal to the principal quantum number. So, for n equal to 3, that is the third orbit, will have 3 subshells. They are 3s, 3p and 3d. Now, n equal to 4. So, we will have 4 subshells, 4s, 4p, 4d and 4f. For n equal to 5, we will have 5s, 5p, 5d, 5f. Now, there can be 5g also, because it will have 5 subshells, that is theoretically, but we have discussed that beyond f the other subshells are not used. So, we will consider up to f only. Now, if we take n equal to 6, then we will have 6s, 6p, 6d, 6f. We will not consider the subshells beyond f. Now, n equal to 7. So, 7s, 7p, 7d, 7f. After this, we don't need. So, we have written the possible orbitals or the possible subshells that will be used. Now, we will draw parallel arrows to predict the sequence according to the Aufbau principle. So, we will draw arrows like this. Okay. So, in these arrows now, what we will do, that we will connect the front of the upper arrow with the end of the lower arrow, like this. Now, this will give us the sequence of filling of orbitals. So, this will go like this. So, 1s, then 2s. The sequence that is given, it is according to the increasing order of the energies. How we will prove it by n+l rule, we will see a bit later. So, first, if we follow this first arrow, what we get? 1s. So, the first one will be 1s. Then if we follow this path, then the next subshell we get is 2s. So the next one will be 2s. Now if we again follow the path, we reach 2p. So 2p. Then we get 3s. After that we get 3p. Then 4s. See, 3d is still left, but first 4s will be filled. 4s. Then if we follow the path, we get 3d. After that 4p, then 5s, then we will get 4d, then 5p, then we will have 6s. After that we will get 4f. See, so 4f is filled later. Before that we get 5p, 6s, after that 4f comes. Then we get 5d, then 6p, then we have 7s. Okay. So now we will see how we can prove the energy values according to the n+L. So for 1s, n equal to 1, s equal to 0. So n+L is 1. For 2s, n is 2, L is 0. So 2. For 2p, 2 plus 1, that is 3. For 3s, 3 plus 0, that is 3. For 3p, 3 plus 1, 4. For 4s, 4 plus 0, 4. For 3d, 3 plus 2, 5. 4p, 4 plus 1, 5. 5s, 5 plus 0, 5. 4 plus 2, 6. 5 plus 1, 6. 6 plus 0, 6. 4 plus 3, 7. 5 plus 2, 7. 6 plus 1, 7, and 7 plus 0, 7. So see, whenever the n+L value is same, the filling of the orbitals are according to the principal quantum number, right? 3d, 4p and 5s all have n+L as 5, but according to the principal quantum number, first 3d will be filled, then 4p, then 4s. But when n+L is greater, then we will not see the principal quantum number. So this was the Aufbau principle, which tells us about the sequence of the filling of the subshells. The other rules we will see in the next part. Thank you.